Good morning, good evening, or good afternoon, everyone. My name is FZSON. Today we will discuss about the results of HPLC. Actually, HPLC gives us results in the form of graph, and this graph is called chromatogram. Chromatogram. This graph represents time on x-axis and absorbance on y-axis. This time is called retention time. Whereas this absorbance represents as MAU, milli absorbance unit. And the line from which different components show different peak is called baseline. This line is called baseline. Okay. As we know that each components of sample show different absorbance at different time. Uh, Suppose this is HPLC column, and we pass our sample through this column. Then each components of sample show different affinity with stationary phase present in HPLC column. So each components will be elute at different times as compared to uh, other components. So each components show different retention time. Retention time, it is the time taken by the sample to move through HPLC column. So each components of sample has different different retention time with each other due to their different affinity with stationary phase present in HPLC column. And the absorbance of each components has different absorbance. Actually in HPLC we use MAU, or milli absorbance unit, because in HPLC the detectors are super sensitive. It can show a small value of absorbance also. Suppose this is sample A, this is sample B, and this is sample C. Sample A has retention time 2, and its absorbance has 5 MAU. The 5 MAU is also written as 0.005 AU. So to avoid this large figure, we can use just 5 MAU, which represents 5 milli absorbance units. The baseline also has some value even at start, because before uh, run the sample through HPLC column, we first pass through the mobile phase in this HPLC column. As we know that mobile phase also has some absorbance, it can absorb light, so it shows some absorbance at start even. Therefore the absorbance line also has some absorbance value at start even. And in start some winding are also here, because when we pass through sample through HPLC column, then the solvent present in our sample will be elute first, and due to this elution of sample or solvent sample, some winding of baseline will be come here. So after that, suppose A has some retention time here, and absorbance of A will be here, and B has retention time here and their absorbance will be here, and C has retention time here and their absorbance will be here. When we draw the peak, so this is A, this is B, and this is C. So this peak of different components will be different, and it has different retention time and different absorbance. In this way we can identify different components of sample through HPLC graph. The time in which the winding of peaks will become, it is called the void time or dead time, and it represents as T0. Sometimes the peaks are asymmetric, means when we divide these peaks, then the first half portion are less wider than as compared to second half portion, then this is called tailing of peak. Tailing of peak. So this type of graph is shown by HPLC, through which we can identify different components of sample. In the next lecture, we can calculate the exact value